हेलो चिल्ड्रन। आज हम सॉलिड हेमिस्फीयर का सेंटर ऑफ मास कैसे निकालते हैं वो देखेंगे। देयर आर टू मेथड्स, सो वन बाय वन वी विल लुक एट इट। वी विल फाइंड center of mass, the center of mass of solid hemisphere. See, this is a hemisphere. Center of the hemisphere is over here. So this is the hemisphere. हम एक select करेंगे two axes. This is x-axis and this is y-axis. This is x-axis and this is y-axis, and origin is the center of the sphere from which this hemisphere is made. So this is the center of the hemisphere. With respect to this coordinate system, I will find the center of mass of the solid hemisphere. So it can be found in two ways. First method I will follow is, I will consider a elementary disk. How? So suppose we are considering this elementary length and this is the elementary disk. Elementary disk is this. Even though it is elementary, I have shown it broader over here. Thickness is taken more because I have to show this length to you to make you understand. In fact, it is very, very thin. This distance is very less. Suppose it is A, this is B. So this length is very small, elementary, very small. Now, since it is a solid, so when we are taking this area and if we find the total circular ring out of it, that this will not be a ring, but it is a solid disk it will be made. So we will find the center of mass of the whole hemisphere. For that, elementary disk is considered, and by method of integration we will find the center of mass of this hemisphere. Let this radius, this is the radius, OA is the radius. This makes an angle theta with y-axis, and this angle is d theta. So we know what is AB. AB is r d theta. And the radius of this disk, since the elementary thickness is very less, very less. So r, this will be, suppose it is r1. So this is equal to r sine theta. That is r sine theta. Why? Suppose it is O1. So O1A upon AO, that is equal to sine theta. So O1A, that is R1, and this is R sine theta. Similarly, if you are taking the vertical distance over here, and this is, suppose it is C. So this is AC is equal to, and see this is theta, this will also be theta. So this will be R cos theta. and center of mass of this elementary disk is O1 and distance of this from here is Y. Because thickness is very less, so center of this disk will be O1 and the distance from this O is the center of mass of this elementary disk, that is Y. Therefore, we can say AC is equal to Y. So this much figure is clear. Now, let the mass of the elementary disk is equal to dm. Right? To consider volume of the elementary disk is equal to what? To understand exactly what the volume is, what I will do, I will make this section separately, because you see, since it is very small, it is almost straight, and this is 90 degree, right? So I will make separate figure for that, and then we will understand. This is something like this, right? I have taken this part. It will look straight if you are taking the section. So it is like this. Center is over here. This is joined, and this vertical distance. This is theta. This is also theta. This is 90 degree. So this angle will be 90 degree minus theta, and therefore this angle will be theta. And this we know. This is A, this is B, this is y-axis, right? And AB is R d theta. Therefore, this point is, suppose we are considering D. So AD will be equal to R d theta sin theta. And this is AD. D point is over here. So AD is the height of the elementary disk. This is the height of the elementary disk. Because when we are going to find, जब हमको volume निकालना है, so we know area of the base into height. So area of the base, radius is this, pi r1 square into height, that is AD. So volume of the elementary disk is pi r1 square into, that is AD height. So pi r1 is r sin theta, so r sin theta square into AD is r d theta sin theta, r d theta sin theta. So this can further be simplified as pi r square sin square theta into r sin theta d theta. That is pi r cube sin cube theta d theta. This is the volume of the elementary disk. This one. Let mass of hemisphere is equal to m, and volume of hemisphere is equal to, what will be this, 2 by 3 pi r cube. Because we know कि total sphere, what is the volume? 4 upon 3 pi r cube. It is hemisphere. Half of that, that is 2 by 3 pi r cube. So, therefore, mass per unit volume, that is equal to rho, and this will be equal to how much? That is m upon 2 by 3 pi r cube, and this is equal to 3m upon 2 pi r cube. Now we will, mass of the elementary disk is dm, therefore dm is equal to, this is volume, and suppose we consider this volume as V, so this will be V volume into density, that is mass per unit volume. So volume we have found this much, so this is equal to, I will write pi r cube sine cube theta d theta into, and the value of this I will write over here, that is pi r cube sine cube theta d theta into 3m upon 2 pi r cube. Okay. Now we can simplify this. See, pi will go with this pi, r cube will go with this r cube, and we will get 3m by 2 sine cube theta d theta. This is dm, mass of this elementary disk. So you will find y is ycm. So we know the formula for ycm, that is equal to y dm upon total mass of the hemisphere. What is y? Y is this distance, center of mass of the elementary disk. Right? Center of mass is over here, this distance is y, and y is equal to what? That is r cos theta. That is integration of r cos theta into dm. dm is this, I have found dm. That is 3m by 2 sine cube theta d theta by this m. What limit we are going to put? See, theta is varying from 0. I am measuring from y-axis. From 0 to pi by 2. If it comes over here, because theta is this, means this much area is getting covered. If theta is somewhat more, new elementary disk will be there. Means if theta is varying from 0 to pi by 2, whole total volume of the hemisphere will be considered. So theta is varying from 0 to pi by 2. So 0 to pi by 2. Now this m will go with this m. So we will get 3r by 2 integration 0 to pi by 2 sine cube theta cos theta d theta. Is it clear? Now we will integrate this. Integration is to be done, and that can be done by the method of substitution. We will substitute sine theta is equal to, suppose, new variable, that is t. Let sine theta is equal to t. Differentiate it with respect to theta, we will get cos theta d theta, that is equal to dt. That is a differentiation of sine theta with respect to theta. Now, limit is from 0 to pi by 2. When theta is equal to 0, this implies t is equal to 0. Because you are putting sine 0 is 0, means t is equal to 0. When theta is equal to pi by 2, this implies t is equal to 1. Because when theta is pi by 2, sine pi by 2 is 1, means t is equal to 1. So limit will change, and accordingly integrand will also change. So we will write 3r by 2 integration of, in place of sin theta we will write t, that is t cube, and cos theta d theta together, cos it is dt. A limit for t is from 0 to 1. So that is equal to 3r by 2 integrating t cube, that is t to the power 4 by 4, limit 0 to 1. Okay. So this is 3r by 2 into 4. I have taken this 4 common outside, that is 1 minus 0. That is 1 to the power 4 minus 0 to the power 4, 1 minus 0. That is equal to 3r by 8. Therefore, YCM is equal to 3r by 8. And what about XCM? By symmetry, you see, by symmetry, x coordinate will be 0 because y, with respect to y axis, it is symmetrical on both the sides, right? So by symmetry, x coordinate will be 0. Therefore, XCM is equal to 0. By symmetry, you can write. Therefore, the coordinates of center of mass is 0 and 3r by 8. So this way we could find the center of mass of hemisphere, solid hemisphere as a matter of fact. So there is another method to find the center of mass of solid hemisphere. So in a similar manner, this is the solid hemisphere, but consideration is slightly different. Now what we have done, I have considered an elementary hemispherical shell. Elementary hemispherical shell. So first we will find the volume of this hemispherical shell. So what is the volume? So volume of elementary hemispherical shell is equal to. So how will we get the volume? The total surface area of the shell into thickness. Thickness I have considered as dr, and total surface area of a sphere is 4 pi r square, as it is half. So we will get 2 pi r square into thickness is dr. This is the volume. And mass of the hemisphere is equal to m, and volume of hemisphere is equal to 2 upon 3 pi r cube. Total sphere is 4 upon 3 pi r cube. Half of that is 2 by 3 pi r cube. Therefore, mass per unit volume is equal to m upon 2 by 3 pi r cube, and this can be written as 3m upon 2 pi r cube, and this is equal to rho. Therefore, this volume, you just imagine it is V. Therefore, mass of elementary shell is equal to V into rho. Base this volume is this, rho is this. So this is equal to 2 pi r square dr into This is 3m upon 2 pi r cube. Volume into density is the mass, simply. So 2 pi and 2 pi will go. We will get simply 3m upon r cube into r square dr. This is the mass of the elementary cell denoted by dm. Therefore, dm is equal to this. Now, we have to find y center of mass, y coordinate of center of mass of this solid hemisphere. So this will first we will find the what is the center of mass of this elementary hemisphere, spherical shell, and we all already know that is half of the radius of this hemispherical shell, that is r by 2. So ycm means this is y dm upon m. And what is this y? Y is the center of mass of dm. Dm is total mass, this is hemispherical shell, and center of mass is at r by 2. So in place of y, I will write r by 2. And what is dm? Dm is this, that 3m upon r cube into r square dr into r square dr. What is the limit I will be putting over here? Limit. You see, r is varying from 0 to capital R. 0 to capital R. The total volume of the hemisphere will be covered. अगर 0 to r में इतना कवर होता है वॉल्यूम, हम 0 से लेकर के कैपिटल R तक लेके जाएंगे, so many spherical hemispherical shells will be made and total volume will get covered. So it will be varying from 0 to capital R. Simplify कर देंगे इसको. This m will go with this m. So what are the constants? 3 upon 2 r cube. 0 to r and r into r square, that is r cube dr. ठीक है? Okay. So 3 upon 2 r cube. इंटीग्रेट कर देंगे r to the power 4 by 4, 0 to r. This 4 I will take out. So 3 upon 2 into 4 r cube, r to the power 4 minus 0. Putting the limit, and this is equal to 3 upon 8 r cube into r to the power 4. This r cube will go with this, that is 3r by 8. Therefore, ycm is equal to 3r by 8. That we got, as we have got in the previous case, in the similar way. This is again ycm, and but xcm is equal to 0 by symmetry about y-axis, right? Therefore, we can write coordinates of center of mass is equal to, this is 0, 3r by 8. So, it is very important. So, I think you have understood it well. So, revise it, look at it, and try to practice by your own. So, children, all the best.